Welcome to Session 4, Inequalities and Absolute Value. Let's go slowly and build it up. An inequality is like an equation, but instead of one answer, it has a whole range of answers. Today we will solve inequalities, graph them on a number line, learn the one rule that trips everyone up, and then handle absolute value. Inequalities describe real limits. Think of a speed limit, a minimum age, or a budget you cannot go over. On the GED, you will solve them almost exactly like equations, with one important exception that we will highlight in bright color. Learn that one rule, and inequalities become easy. First, know the symbols. The open point symbols mean strictly greater than or strictly less than. The symbols with a line underneath mean greater than or equal to and less than or equal to. A helpful tip: the small pointed end always points to the smaller value, so the arrow opens toward the bigger number. We show the answer on a number line. Here's the key: use an open circle for greater than or less than, because that number is not included. Use a closed, filled circle for greater than or equal to, because that number is included. Then shade the arrow toward all the values that work. This graph shows x is greater than 2. Solving an inequality uses the same balancing idea as an equation. 4x plus 4 is less than 9. Subtract 4 from both sides. That leaves x is less than 5. The inequality symbol does not change because we only added or subtracted. The answer is every number below 5. Here's the one rule everyone must remember. When you multiply or divide both sides by a negative number, you must flip the inequality sign. Look at negative 2x is less than 6. Divide both sides by negative 2, and the less than becomes greater than. So x is greater than negative 3. Flip the sign every single time you divide by a negative. Two-step inequalities work like two-step equations. For 3x minus 5 is greater than or equal to 7, first add 5 to both sides to get 3x is greater than or equal to 12. Then divide by 3. Because 3 is positive, we do not flip, so x is greater than or equal to 4. Sometimes x is trapped between two numbers. This is an AND inequality. Read negative 1 is less than x, which is less than or equal to 4, as x is between negative 1 and 4. Whatever you do it to all three parts at the same time. The solution is the piece in the middle. An OR inequality points in two opposite directions. Read x is less than negative 2 or x is greater than 3. The solution is two separate rays that do not touch. Use OR when the answer splits apart, and when the answer stays together in the middle. Now to absolute value. The bars around a number mean its distance from 0, and distance is never negative. The absolute value of 5 is 5. The absolute value of negative 5 is also 5, because negative 5 is 5 steps away from 0. Both point to the same distance. Because two different numbers share the same distance, an absolute value equation usually has two answers. For the absolute value of x equals 7, x could be positive 7 or negative 7. Always split it into two cases. The inside equals the positive value, or the inside equals the negative value. When there is an expression inside, isolate the bars first, then split. For the absolute value of 2x minus 1 equals 9, set up two equations. 2x minus 1 equals 9 gives x equals 5. 2x minus 1 equals negative 9 gives x equals negative 4. So there are two solutions, 5 and negative 4. Let's use an inequality in real life. A ride can carry at most 400 kilograms. Each rider averages 80 kilograms. How many riders are allowed? Write 80r is less than or equal to 400. Divide both sides by 80, so r is less than or equal to 5. At most, 5 riders can go on. Keep these traps in mind. Flip the sign only when you multiply or divide by a negative, never when you simply add or subtract. Use an open circle for strictly greater or less, and a filled circle when it is equal. And remember, an absolute value equation almost always gives two answers, not one. Well done. You can now solve inequalities, graph them, flip the sign at the right moment, and handle absolute value. To read the full lesson notes, see more worked examples, and practice GED questions, visit the course page at www.bridgetoexam.com. Practice a few today. See you in session 5, where we explore functions and graphs.